Okay, we're going to start our next part of this week's lessons, which is we will calculate the surface area of nets and three-dimensional solids. And those three-dimensional solids in 5th grade we're going to work on surface area with are rectangular prisms and cubes. So the first thing we're going to talk about is a little bit of vocabulary. We have not talked about surface area yet. So right here, I'm going to underline it up at the top. Here is our definition for surface area. Surface area is the sum, which means total, of the area of all of the faces of a solid. So usually when we're talking about area, we're talking about flat shapes, such as this from yesterday. Remember, we did a little bit of a review with just rectangles and squares. But we know that solids are created from a combination of those flat surfaces. Right here, you see a cube and a net of that cube. Remember, the net is the flat representation of this solid. So if we were able to take this solid cube here and unfold it, this net is what you would see. Okay, and today we're going to really work on finding surface area of nets. So first I would like you to think, what do we already know about cubes? And just like squares, what you know about cubes from 2 weeks ago is that all of the faces, all 6 of the faces of a cube are identical. They have the same base and same height. The length, the width, and the height of the cube are all 4 inches, and that will help us in finding surface area. Now, finding surface area of cubes is a little bit different than rectangular prisms. We're actually going to take our shortcut, our easy win first, and then we're going to work on rectangular prisms, which are much more difficult. Hopefully in this net, you're seeing that all 6 of the faces are exactly the same. And we know from looking at our cube that our base and height values for each one of these flat shapes are going to be 4 and 4. So I'm going to just go ahead and label one of these first. I know that, let's start with this bottom one. I'm going to kind of outline it with my red marker here. And I know that my base of this flat rectangle is 4 inches. And I also know that my height of this flat rectangle is 4 inches. To find surface area, because we're finding the sum of the area of all the faces, we're going to find the area of one face of the cube first. And then we're going to think about, again, what we know about cubes, that all of the 6 faces are identical. So I'm going to start by finding the area of just this one face. And again, I'm going to go back to that area formula. Area equals base times height, or length times width. And then I'm going to plug in our numbers here from our square, 4 times 4. And that tells me that the area of this one face that I've drawn out that arrow from is 16 square inches. Oh, sorry, that got a little messy there. So if I know that the area of this face is 16 square inches, think about what that means about this face, and this face, and this face, and this face, and this face. Again, you know that all 6 of the faces of a cube are identical because they all have the same base and height measurements. Okay. Now, when you are doing this unit on surface area, and just like the last unit with volume, if you would like to use a calculator to check your work, you are more than welcome. This unit is not about how well you can multiply. If I find that the area of one face is equal to 16 square inches, and I know that I have a total of 6 faces, what I can do to find my total surface area is to multiply the area of one face, 16, times how many faces there are. 1, 2, 3, 4, 5, 6. So to multiply 16 times 6, that will give me my total surface area. And I am going to, again, remind you that because this is flat, we're finding the surface area of a net, or we're just finding area, it is going to be in square inches, not in cubic inches. Remember, we're not finding volume, we're finding area. I'm going to do this with the standard algorithm here, multiply 16 times 6. You can do that as well on your independent practice, or if you want to do your work another way, use repeated addition, or even the area model, that would be okay. I know 6 times 6 is 36. 6 times 1 is 6, plus 3 is 9. 96. So our answer for the total surface area of this cube is 96 square inches. I'm going to box that in so it kind of stands out. I know it got a little bit messy. Okay, now we're going to be doing this again, finding the surface area of this rectangular prism here. And here is a net of that rectangular prism. Now, you guys might also notice that there's some grid lines in the net that we can use to count and write our side lengths. But I'm also going to try and encourage you and challenge you to use the ones that you see on your rectangular prism to kind of help you visualize doing this with nets. I'm going to start here at the bottom, and I'm going to count 1, 2, 3, 4. So I'm going to label this side right here 4 centimeters, and that makes sense. That would be this side right here. And then right here, this long side is going to be our height measure, which is 7, or I could count up those 7 boxes. That means to find the area of just this one face, I'm going to be multiplying 4 times 7. Now, I'm going to do that first before we fill in any of the other ones of our values. I am going to call this face our front face. And I think you'll understand why in a little bit. So the area that we're finding, and I'm going to shade it in over here on our solid, is actually this face right here. And I already grabbed my height and my base from looking at our rectangular prism or by counting our units. So I'm just going to do this quick. I'm not going to write down the area formula right here. I'm going to write it over here. I know that my area of my front face is equal to, and I'm going to just write our area formula on the top here, base times height. My base is 4. My height is 7. 7 times 4 is equal to 28. And again, we do square centimeters. We'll get to that at the end because we're going to have to find the area of each one of these faces and add it all up to find our total surface area. Okay, so I'm going to write just 28 in here because I know the area of that face is 28. You could double check that by counting all the little squares in there if you'd like to, or again, multiplying 7 times 4, 4 times 7. Now, I'm hoping what you notice is that there is a face that looks exactly like that face we just found the area of, and it has the same measurements of 4 centimeters and 7 centimeters. That means that the area of this face is also 28 square centimeters. Now, I'm going to call this the back face. And that is the face of the solid that would be back here that we can't see. Because we know the front and the back, they are equal. They will have the same measurements and they will have the same area. Four times 7 equals 28. Okay, now I'm going to kind of erase some of this stuff so we don't get too jumbled up because we're going to have to find our other 4 faces of our rectangular prism. Okay, and I'm going to use red. I hope this doesn't get too messy. Now, what I'd like to do real quick is work on our top face. And I just did that one in red on the solid. I'm also going to use red when I write on it or measure it with the net. Okay, now I'm going to kind of outline this one in red. I see that I'm going to use my 4 centimeters here, which is the same 4 centimeters as here or this side. And then my width, or my height of that exact rectangle, is going to be 3 centimeters. Okay. Now, again, I'm going to call this one our top face. And our area equals 4 times 3 equals 12 square centimeters. And I'm hoping you're noticing, oh, wow, hey, yeah, there is an equal face. And that would actually be our bottom face, way on the bottom here of our rectangular prism that we can't see. So I'm going to call that the bottom. And that is area equals 4 times 3 as well. I'm going to try and squeeze this in here. Equals 12 square centimeters. Okay. So if this is 12 square centimeters, then this same face that is equal also has to be 12 square centimeters. I'm hoping this is not getting too confusing. I'm going to keep erasing this stuff. And I'll rewrite those values in when we go to total them up. Okay, now I'm going to use green. And now we are going to find, I'm going to call this our side. Let's start, that's on the left side. So let's call this left side. And area equals, okay. So that is going to be this face here. And I kind of outlined it in green over here on your solid. So think about what numbers make up that side of our rectangle. Oh, 3 and 7. 7 centimeters is our height. 3 centimeters is our base. And to find the area of that, we would multiply 3 times 7 equals 21. Okay. And then I'm hoping you also see, hey, yeah, right here. This is our right side. and that is also equal to 7 times 3 is 21. Okay, now I'm going to erase the things that are on this, and I'm going to kind of plug our values back in so you can see all of them at the same time on our net. Try and use the same colors, so 21, 21, 28, 28, and 12, and 12. Okay, now for us to find our total surface area, what we're going to have to do is add all of these up. It is the sum of the area of all the faces. So we found our faces, and we found the faces that were equal to them, like the front and the back, the top and the bottom, the left side and the right side. Okay, now we have to add all of these together. If you would like to use a calculator to check your work, that is totally okay. I would really like you to try and practice all of those addition strategies or grouping strategies that we've been trying in 5th grade. So I'm going to do that, and I'm going to actually use this yellow marker to try and make this stand out a little bit. First, I'm going to start with my numbers in my 1 spot, and I admit I could have done a little bit better job adding these up or lining them up so they were easy to see. I'm going to group 10s here. I see that 8 plus 2 is 10, and 8 plus 2 is another 10, and then I just have my 2 1s left. So that means that we have 22. And then I'm going to do the same thing over here. Okay, I see a 2, 4, 6, 8, 10, 12. Okay, so I got a total of 122. If I had a calculator right next to me, like I'm hoping that you will be pulling up on your Chromebook, that you will check out your work too. Our total surface area is equal to 122 square centimeters. Okay, moving on to another cube, and you will probably start to find these being the easier ones. I see here that we only have one side of our cube, but one thing that you know about cubes, again, think, what do you know about cubes? All of the side lengths are exactly the same because cubes are made from flat squares. So I know that this will also be 7 inches, and my height will also be 7 inches. I'm going to highlight one of these rectangles, and that's what we're going to use, or squares, I'm sorry. That's what we're going to use to find the surface area of the cube. Now, the cube is easy. We don't have to do that top, bottom, left side, right side, front face, back face, because all the faces are identical. So if we are able to find the area of one face, we can multiply it by times 6 for how many faces we have. Okay. Again, we're going to kind of use our solid here to label our sides. If all of the sides of this are squares, that means that they all have to be 7 inches, 7 inches. We're going to use that to find the area of one face. Area equals base times height, or length times width. I'm going to plug those numbers in. 7 times 7. 7 times 7 is 49. Okay, so I know the area of this one face right here is 49 square inches. So what I can do is multiply that instead of going through and finding the opposite face is equal. I know that they're all the same. So if that face is 49, this face is also 49. All 6 of them are 49. If you want to use repeated addition to do that, you can. I'm going to right here use a standard algorithm. 9 times 6 is 54. 6 times 4 is 24 plus 5 is 29. So our surface area equals 294 square inches. Okay, this is going to be the last one we do today. I know this is a really long mini lesson, but this will help us when we start to do surface area with solids. Here you see a rectangular prism, and next to it is the net of this same rectangular prism. Now this time we don't have any of those grid lines in there to see our square units, so instead we're going to have to kind of use our solid to help us label this. Now I notice right here that the length of our prism is 10 centimeters. So that means that over here on the net, all of those long sides, I'm going to start here, are 10 centimeters. Okay. Now let's start with this face right here, and we're going to actually call this face, um, let's call this our top, because I see that this face is the same as this face here. Okay. Now think about what numbers would be used to find the area of that top face. What side lengths? If I know this side right here is 5 centimeters, that means the side here is also 5 centimeters. So I'm going to label that right here. And then to find our area, we're going to multiply 5 times 10 equals 50 square centimeters. Okay, now I know that the bottom face, this one here, that we can see through this in our solid, the bottom face is the same area as that and uses those same measures, 10 centimeters and 5 centimeters. That is this face here. 5 times 10 equals 50. Okay, on our last slide, what we did is we broke that up and wrote this over here too, because we aren't always going to have the net to help us see that other face. So I'm going to write this as our top. Oops, sorry. Our top face is 5 times 10 equals 50. And what we can do, since we know our top and our bottom, I'm going to write bottom underneath here. Our bottom is the same. We can either multiply 50 times 2. Yeah, let's do that. Let's do 50 times 2 because we're counting that for our top and our bottom. 50 times 2 is 100. And we don't have to write out that area formula again because we already did it here. Okay, now I'm going to move on and I'm going to use, we're going to use our blue marker here, and we're actually going to find the area of this front face right here that I'm coloring blue on our solid. And that is going to be the same as this face right here. Again, we're going to be using our long side here, which is 10 centimeters. And the other side we're going to use to find this is our height, which we already know from here. This side and this side are the same. So to find the area of this face, we're going to multiply 2 times 10 equals 20 square centimeters. I'm going to write that over here. We're going to call that our front face. So 2 times 10 equals 20. And right here in our solid, I'm going to kind of color it in. It looks a little bit weird, but we also have a face that is equal to that, which is our back face. So we're going to do that same thing where we multiply our 20 times 2 because we have 2 equal faces. That is this face here with sides of 2 and 10. So we're going to do 10 times 2 equals 40 square centimeters. Okay, now I'm going to use green for our last 2 faces, which are these side faces. I'm going to use green right here. Okay, now when we do this, these are both sides. I'm going to call this one our left side. Side 1 or side 2 also works to kind of keep them separate, even though you know they're the same. And I'm going to label right here, we're going to be multiplying 2 times 5. Because here and here, those are the measurements that make up that face. And I know that 2 times 5 equals 10. The area of that face is 10 square centimeters. And this right side has the same area. So I'm not even going to rewrite this 2 times 5. I'm just going to multiply that one face that we found, the left side, times 2. And 10 times 2 is 20. So we just found this face and this face. Okay, now to find our total surface area, I'm going to write that down here. We need to add the area of each one of our 6 faces that we found. Okay, so I'm going to start here with my ones. 0 plus 0 plus 0 is 0, and 0 plus 4 plus 2 is 6, and 1 plus 0 is 1. Okay, so here's our surface area, 160 square centimeters. Okay, real quick here, I see something that I wrote wrong on our model, and it's right here. This should say 10. Okay, got it. Okay, looks good. 160 square centimeters is our total surface area.